Hello and welcome to week 3. Hopefully you're getting situated in the course and you're comfortable with how things are working. So in week 3, more of the same workflow again from top to bottom. Just a quick reminder there, and probably the last reminder to take good notes when you learn the content, be organized, and clearly indicate which video you're taking notes on. So if you ever need to go back and reference it, you're able to do so. So week 3 due dates again, always by 11:59 p.m. You're probably used to it by now. Discussion board Wednesday, homework due Sunday, and there's no quiz this week. We have them approximately every 2 weeks. So this week we'll be focusing on a discussion board related to the last discussion board about, well, I read that a lot of you described ways in which you could possibly correct the system so that it would be possible to find a realistic solution. And some of you mentioned and proposed some insights into how to do that, so that was great to read. In this discussion board, you'll do that in several different ways. Okay, so how do we adjust this model? Because clearly a mathematical solution does exist, but mathematical solution doesn't always mean practical solution. So mathematics does its job, but we have to make the system feasible and make the constraints feasible. So this week we'll be taking a look at a different kind of optimization or problem solving called linear programming, where we still have constraints, but those constraints give us at most a certain budget, or we have to make at least a certain number of parts, and so it ends up dealing with inequalities, less than or equal to, greater than or equal to. And then given those constraints, we often want to maximize or minimize an objective function. So it's kind of like the idea in calculus, except there's no calculus involved in this. It's all dealing with linear functions. I'll go ahead and finally just wrap up the discussion board on when systems fail. So I think a lot of us did a really great job of approaching this. But one thing that I want to point out that's really important when we're talking about defining variables is, number one, we need to define them, and we need to be very careful to say, what measurement are we taking? Well, if I just say floor ticket and I say seat ticket, what am I measuring regarding the floor ticket? Well, I'm measuring the price. And as evident as that may seem to most of us, it can go unnoticed. For example, somebody reads X as floor ticket. Well, what is it? Is it the number of floor tickets? Is it the size of a floor seat, or the size of the space for the floor ticket? I mean, there's so many different things we can measure. Even though it's apparent to you, it might not be apparent to somebody else. And then later on, when we go back and we say, oh, well, we found that X equals blank and Y equals blank, we know exactly what those quantities are and what they're measuring. So we know that they're going to be, this is what we should charge for the price of a floor ticket in dollars. Okay, so our constraints were in words. We wanted the average ticket price to be $20, and we wanted to get an exact revenue of $25,750. So realistically, in like the linear programming stuff we're going to look over in this coming week, we would want at least a revenue of that amount, right? It's not like that's the magic number that's going to solve all of our problems. Right now, we just said let's force it to be exactly that, but realistically, we might want it to be at least that amount, right? Probably the more money you make, the better. And maybe we want the average ticket price to be at least $20. So, and we want to maybe maximize our profit or something else. In any case, now we need to mathematize these. So I want the average ticket price to be $20. Well, how do you find an average? An average is, we take the sum of the ticket prices and divide by the number of ticket prices to find the average ticket price. So what are the ticket prices? Well, one of them is X, and one of them is Y. And by the way, another way of thinking about this is we want to make sure that what we have is what we need. So what we have, our average ticket price based on the dollars per floor seat and the dollars per, the dollar per floor ticket, and the price for a floor ticket and the price for a seat ticket are X and Y dollars. So our average will be X plus Y over 2. Now we need that to equal $20. See how much easier that is? We say what we have is this, what we need is 20. Again, what I will have in my revenue is 500 floor tickets at X dollars per floor ticket. So I'll have 500 times X total dollars contributed to me by selling floor tickets. And then 250 seat tickets at Y dollars per seat ticket. So 250 times Y will give me my total income from the seat tickets. And then if I add the seat ticket total revenue to the floor ticket total revenue, that's the revenue that I have, but I need that to be $25,750. Great. So we can solve in a number of different ways, graphically, algebraically, using matrices. So you can use Desmos in place of GeoGebra. I think a lot of people did. It's a lot easier. So we enter our two equations in here, and then we see that we get this intersection point right there. Well, that intersection point occurs at x equals 63 and y equals negative 23. Well, I wonder what that means. Well, because I can go back here and I say, oh, x is the price of the floor ticket and y is the price of the seat ticket, I know that the price of the floor ticket needs to be $63 and the price of a seat ticket, I might have just said that backwards, needs to be negative $23. Well, clearly that doesn't make sense. Mathematically, that's an okay solution, but not practically speaking. So, practical conclusion is that the constraints cannot realistically be satisfied. They can mathematically be satisfied, but we need to make some modifications to these constraints. Well, that's our task for next week in the discussion board. You'll get to actually do this in a number of different ways and use sliders in the process. So that's it. Have a great week. Look forward to seeing you in the next discussion board, and see you in week 4.